Welcome, everyone. I hope you will enjoy this today's session about REST. I know that REST is, let's say, a mainstream subject, and everyone is implementing REST APIs. But I'm going to ask you now, and I'm going to wait for the answer at the end of the talk. Who here ever did REST APIs? And I'm going to just try to ask you at the end of the talk if you still did REST APIs. Okay, my name is Irina Scurtu. I'm from Romania. I'm design lead because that's the way the company calls the position. I'm actually a software architect at Endava, and I'm also a .NET Group community lead, which means that I'm taking care of everything .NET related inside the company across the world. I'm also a Microsoft MVP for developer technology, and I'm also passionate about everything .NET. So if I were to talk about something, that topic would be .NET or something related to it. Okay, so in today's agenda, we have a few things. A few we're gonna deep dive, and a few of them we're gonna just touch a bit. Well, we're gonna talk about REST, and we cannot talk about REST without talking HTTP. We're gonna talk about HATEOAS just a bit, and about versioning. So what is REST? Representational state transfer. It is that concept that I remember when it was taught to me in faculty a lot of years ago. It was so difficult. And I consider it difficult until I learned that the whole thing around REST is actually HTTP based. REST is used everywhere, but when you're actually looking at the code that's written by a lot of developers, no matter the company, is not implemented. Everyone is saying that it's doing REST APIs, but when you really look at the code and the principles, those APIs are kind of REST-ish, okay? Just being maybe just JSON over HTTP or something like that, but some of them have nothing in common with REST. When I moved towards architecture, I started to make audits on different projects and to work with a lot of teams. And inside those teams, I've noticed a lot of guidelines that are in REST that are not used or followed, or nobody pays attention. So REST has a few constraints, but these constraints shouldn't be called like that, just because if those were constraints, everyone would follow them. But let's call them guidelines, right? There is a guide on how to do things in order to achieve something. So first of all, we cannot talk about REST without talking about client server. I don't know if you work in .NET world, but I also did ASP applications, old ASP, and MVC and web forms. And the paradigm a few years ago was that everything was self-contained. It was a big monolith where you render from the server side the HTML, and you serve that HTML to the client, to the browser. But now the paradigm is changing. It's mainstream right now to have a server that is an independent entity and to have a client that is written in whatever JS that consumes that API, that data that comes from the server. So that's one of the constraints. And I think here we all had this constraint like checked, right? So the second constraint it's about the state. As HTTP, your REST API should be stateless, should maintain absolutely nothing related to the previous request or the request that will follow. Being stateless means that you should maintain no state. And if you want to maintain a sort of state, that state should be self-contained in the request. The next constraint is caching. Caching is one of the most important specs of web and HTTP, and you should use a cache. It depends on where you are on the perspective, if you are on the server or on the client, but to cache things is very important because it speeds up the perceived performance. Because you're saying, hey, client, take this and hold it in your browser, and next time when you have this, just use it from the browser, don't call me back or something like that. The fourth constraint is the uniform interface that puts a lot of problems to the developers because naming is hard and having a uniform interface for your API is even harder. Layer system says basically that you shouldn't talk with, you shouldn't care if you're talking with a proxy or anything else, as long as you receive the response and that response is the expected one. You shouldn't care. You shouldn't care if you have a proxy or a gateway in the middle. And the sixth constraint that is not used and not so important is code on demand. The server has the ability of sending code to the client to be executed. Apparently, I hope that my laptop didn't die. Okay, so taking everything into particular, we're going to talk about client server. Says that the server is not aware of the client and the server shouldn't care who is the client. The server should look at the request, interpret it, and respond with what's expected in that. What it does, the server, is to do data transformation under the hood. And the client, when receives the response, it will simply use that resource, and that's it. So how it looks like is a simple and the most basic architecture out there, client server, okay? So being stateless, it's a bit slow. I'm pressing a lot of buttons, but it doesn't answer. Stateless. Back in the days, we used to have a lot of mechanisms that allowed us to maintain states. If you work with web forms, you have hidden fields in the page or even in MVC. You store data in the browser, in the page, in hidden fields in order to pass them back and forth towards the server and back. You had cookies, you had sessions, long-lived sessions and everything, and many other mechanisms. But now, if you're talking about REST, these mechanisms, you should forget about those. It's like these are never there. So next part, the caching. The server is the one that controls what resource must be marked as cacheable, and for how long. How it's done is done through headers, the usage of the correct headers, because as an effect, it may increase the perceived performance. And as a consequence, it might save you database round trips, especially if you have data that doesn't change very often, or you identify patterns in your app that can save you a few database round trips. It's very important because not only it saves you database round trips, it saves you network data transportation, and hence the speed up that the client perceives. Okay, so I already mentioned is run to correct usage of headers. Okay, the layers system says that the client talks with an intermediate, it only receives the resource, and it doesn't matter what's in the middle, if it is a load balancer, a proxy, or whatever gateway. Okay. The fourth and the most important spec or constraint is that having a uniform resource means that you treat everything like a resource. No matter what's the business domain becomes resources. You work with resources. You're not working with method calls or what else, resource. Okay, everything is resource based. What is a resource? Anything that can have a name. So more than that, everything that can have a name should also have an URL, should be also addressable. And when you're working with different types of data, you're working with representations of resources. You shouldn't send to the client the actual tables that you have in the database. You should transform those. You should extract everything that is actually needed in that client, for that client, and send the response. You shouldn't pick everything and shove it in the response and voila, that's the response that the client receives. You transform data. So this uniform interface has a few sub-constraints that said that in order to put your hand on those resources, you should identify them in a unique way. And that representation of the resources should also be self-descriptive. And in a uniform resource approach, you should also use hypermedia as the application state, which we must admit, we kind of never implement in our REST APIs. We ignore this, and we're motivating the ignoring part just because we think it adds overhead. Or the lack of tooling, at least in .NET world, is to blame. If we would have a cool library that would aid us in implementing HATEOAS, it would be easier. A lot of us, I think, would go to and implement this. But to do this by hand, it's not so cool because we're always moving on and we're always in a rush to implement functionality for our customers and for the products we're working with. But let's have a look at these. How do we identify resources? Because the addressability to a resource and the fact that it shouldn't correspond to a database table and it can be a subset or a transformed entity, it's hard. I mean, you have sometimes a lot of objects inside your domain that you cannot put a name on. Or if you put a name on, you might find that, well, maybe the naming is so bad that nobody inside your team will understand, or the business guys or girls in your team won't be able to tell what's that resource you're referring to. And everyone should have a common name. So let's have a look at this childish example. I'm pressing the next for the slide, but it doesn't show up. So I apologize if a lot of things will show up at once. So how would you implement something, an API, to represent everything we have in here? Domain objects. Looking that we have sheep, dogs, cats. We have something that is food related. We have farm animals. We have pets. If you were to put everything under the same umbrella inside an API, it would be very hard. And if you think that these are resources, these resources should be named in a very intuitive manner. But let's take an example. If we were to look at a specific thing, a cat that is also black, an operation that might be valid right now might be something like to get the cat location. Or another one can be something like the ability to add a new cat, or maybe to feed the cat, or to get all cats, or get all black cats, and get their hunger level, and maybe you want to find out who are the owners. But if you look at all these endpoints, all endpoints have either a verb inside the name, and they're very different. And this is very bad. If you ever did this, I think you also know that this is bad. It's hard to remember, and it's very soapish. If you work with soap before, you remember that whistle part was ugly, and it gave you a lot of operations. And these kind of endpoint namings are not cool and are not REST, okay? So how do you manipulate resources to representation? Because the client shouldn't interact directly with the domain objects. It will send representations of the resources to be updated, for example. And how does it do that? Well, in REST, everything should be self-descriptive. And being self-descriptive means that everything that is going over HTTP, either a request, either a response, should include details and meaning. And also, if you were from a multitude of requests or response, if you were to take one of them and you look at that, you should be able to tell what's in that. So if it's a request, you should be able to tell it's expected from the server, what you should get back. So that's why we have headers, that's why we have verbs, and that's why we have custom headers, right? So self-descriptive messages, it's a thing that we often ignore. We ignore to add, for example, the proper verbs. I also did it. I also used post for updating a thing. I remember 10 years ago, that's how the things were done. And I also followed the patterns that were already in the team I was. So using post to update something maybe is not the correct way to do things. Media types. And when I say media types, I'm referring to the things that are not application/JSON or application/XML. Custom media types to help us send back to the client a different representation of the resources. I kind of didn't do that until a few years ago. We know the custom MIME types and we use those, and that's it. Headers. Well, headers, except the common and known ones, again, it wasn't something that I used to do. I didn't add custom headers to pass data or pass information to the server and so on to help the server understand what I wanted. And also the status codes. I remember I used just a few of them, and I didn't know there are 63 of them. Okay, I must admit, there are a few of them, like I'm a teapot or something like that, that I do not find the correct usage for it, but most of them are there to give meaning to the responses. So in fact, and enough with this, REST means leveraging the HTTP power. REST means leveraging the underlying protocol power, and we often ignore that. But let's talk about endpoints, because in my experience, in endpoints, when you are talking about endpoints and you see them written in a certain manner, you'll realize that behind the endpoint, it's even worse. So actually, in REST, to represent each resource, no matter the resource, you will need two URLs for each resource. And using different things, you'll have the create, read, update, delete that we all meet inside our applications. Every application has an administration part where it has CRUD implemented. So first of all, for example, if we were to have a collection, speakers get all. Okay, you can tell that the endpoint will get all the speakers that are in the system, okay? Versus speakers without the get all. Which of these is more understandable? Okay, you might say that both of them are easy to understand, but the simple one, speakers, it's more intuitive. And it's more intuitive because you'll see that once you add the correct verb, it becomes very powerful. For an element, you might have something like speakers, get speaker, and then you pass the ID as a query string parameter. How about having and respecting the convention, speaker/ID, okay? Having these two, the simple ones, you can represent and use get as a verb to get the entire collection. You can use post to create a new item. And then for a single element, you might use get to get the specific item with the ID that you specify. Post to maybe create a sub-item. Okay, maybe it's something related to a speaker and you want to add that. You can use post. And also, you can use a put, a patch, and of course, why not, a delete. And I'm waiting for the delete to appear. Okay, so everything it's necessary to represent something, okay? And it's another thing in REST, cool URIs don't change. Because once you implement something and you put it on the web, it's very hard to change it in its entirety without breaking existing consumers. And we often should avoid to do that. So as a guideline, when we're talking about naming the endpoints, you should have concrete things, and every variation for that resource should be in the query string. You shouldn't have different endpoints. Just for example, if you want to get all black cats inside your system, and you have the cat endpoint, you should have a totally separate endpoint. Think about it. First of all, you'll have an extra endpoint that you'll need to maintain. It's an extra code, an entire action in your API that you need to write. And then if the business changes and you want to get all pink cats, you'll have another endpoint that you need to maintain with another extra code. And us as developers, we kind of want to be productive. So why not add a parameter with a color and the list of colors that you support, maybe, and you treat that as a filter. It's super easy to do that. So if we are to talk about status codes, I want to give an example about what should the status code mean. For example, if you look on the left-hand side, you have a response. It's a postman snip. And the status for this is OK. But when you send it to 100 OK, the client should expect that the actual response. But look at the body of the response. It's code 401, and the message is an invalid API key. Please see that stuff. So, well, you server, what do you mean? My answer is, okay, I mean, should I get actual data to be that are usable, or I have an invalid API key? So 200 should mean 200 with the response body, okay? 201 is particular. First of all, it starts with 2, which means that is a success status code, but in particular, it means created. And because it means created, should be returned as a result for a post action that ends up adding a new resource in your database. With also a header location that specify, hey, here's the URL for the new created resource. 202 accepted in scenarios where you send something, but you do not necessarily need a response now. For example, you just send something to enqueue something, or I don't know, just send something for like sending an email. You send the email, you're not necessarily want that status, if it's received or not, immediately. 204, no content, after deleting a resource, for example. 400, bad request. But this about bad requests is debatable, because I've seen a lot of developers using bad requests for everything. If the model is not valid, it's bad request. If the URL is not correct, it's bad request. If the route is not correct, it's bad. Shouldn't be. 405, for method not allowed. So what this means that you are using an HTTP method that the server doesn't allow or doesn't want to interpret. And in response, this will be something that is sent back. 406 should be also used if you tweak it, at least in .NET, to see the automatic response. So you as a client expect certain format of the response. You expect maybe an XML, but the server doesn't know how to write you XML, and because the server doesn't know, it will answer with the 406. Okay, so 406 it's related to the accept header. 409 conflict. Let's take an example that is maybe dummy. If you have a business rule that doesn't allow 2 items with the same field. For example, you have users that shouldn't have the same email address. It's not a bad request if you try to re-register, for example, with the same email address. It's not a bad request. The request is okay. You have the right email format, a valid format for the email. You have a username or whatever else is needed there. You filled out everything, but you get back bad requests. No, you shouldn't get back bad requests because the request is good. But you as a business, you have a rule that says that you cannot create 2 users with the same email. So you have a 409 conflict. That conflict is due to something that is internal to your business, not to the request that the user is sending. 415, unsupported media type. This is related to the content, a content type header. It's basically stating that the server doesn't know how to read what you're sending in the body, and it answers accordingly. 422, unprocessable entity, is the status code that I use when it's a validation error. And I'm going to show you in a demo how you can tweak this to return this automatically. Okay? The opinions are shared here. A lot of folks in the industry are using bad request again, and a lot of them are using 422 to mean unprocessable entity. You're sending an entity that is not processable on the server because of the whatever business rules you have. Okay, verbs. We all know the verbs, right? So get, post, put, delete. And you have a CRUD operation, right? But how about head? And I'm going to ask you how many of you are using head to check with to check if something is there. You're not using it. I know, because I didn't use it until recently. Options. If you have an Angular or React client app, you'll see that options is the request is made by default there. But we should also take into consideration options and to implement it ourselves in order to limit some security issues there. Trace, it's another verb that can be used if you have the right scenario. But what I want to keep in mind is that head and options are also verbs to be used. Okay, so how you describe errors? We often, when it comes to errors inside our APIs, we do not have a standard format. We start with an API, and if you have a microservice architecture, you might end up with a lot of error formats. You might have an array, you might have something that is generic or just standard object. But there are things that are standardized. For example, there is a MIME type that should be sent back with the response, and it's called application problem plus JSON. This is the content type of the response, and it has a specific problem. So it says that you have the type, the title, the detail, the instance where the issue happened, and some other things. So it's up to you how you tweak this, but you should use the MIME type in order to be generic and understandable for the World Wide Web. Application VND API.json. It's another standard format that has errors as being arrays of objects. And that arrays are namely errors, and inside you have objects, items, with source, title, and detail. You can also tweak them, but this is the standard one. It's out of the box, okay? What package you can use in .NET in order to achieve this, VND API.json, is JSON API.NET Core. And you'll get this out of the box, okay? Cool. Versioning, I think, is one of the most, how to put this, not overlooked, totally ignored part in REST APIs. And if I were to show you this, how many of you still have this v1 in your APIs? You have Michael API / API / v1, and that result, because this is the default thing that we do. We start implementing a new API, and we add that v1 in there because we think that it will be versioned, and we forget about that. We never change it. But if we ever change it, that v1 becomes v2, and the URL changes entirely. And by URL changing means breaking the existing consumers. And that's not a cool thing to do because cool URIs don't change. So you need to think about a different way of versioning, except adding in the URL path the v1 or v2 or whatever you have in there. You need to avoid the URL changing by any means. So I'm going to show you here a quote that is said by Roy Fielding in 2013 on Twitter. That says like this: the reason to make a real REST API is to get evolvability. And a V1 is a middle finger to your API customers, indicating that in fact you are doing RPC or JSON over HTTP, not actual REST. Okay? So you add V1 in the path of the URL, well, you show a middle finger to your customers, hoping that you ever change that V1. Because from my experience, I also did it. I'm to blame. I did that. Hey, let's version our API. The first thing that you do when you start a new project, that it's a web API, add V1, change the routes, V1, all cool. You never change that. So what are your versioning options? So first of all, it's in the URL, but not in the URL path. Add it anywhere but in the path. You can add it as a query string, or you can also add in header, okay? So enough with the talk, let's see some code. So I have here a small API that is trying to zoom in, and I'm waiting for the zoom to show up. It won't show up, so I'm going to forget about this. So I have an API, a web API project that also has two other projects. It's data that has repositories, small repositories, and it has another library with the domain. I like to split it that way for demos because I think it's easier to understand for junior people, because in here you'll have everything that it represents: the database, the domain objects, and you can tweak them, you can extend them. In the data, you have the repositories. Let's see if it works. I clicked and I'm waiting. And it's nothing else than Entity Framework and SQL Server. And it looks like this. It's talk repository to represent the conference. We are at the conference, and I thought that this is a good example. We have a speaker repository that it adds, it deletes, and so on. It's crawled basically over a speaker's table. And the conference API, okay? And the conference API has two controllers. You see more of them, but it represents two data types, speakers. And what we have in here is the traditional route, API, and the controller name. And this is very, very easy. You have, for example, an HTTP GET to get all the speakers. And I also have Postman collection that we're going to walk through in order to show you how you can tweak .NET API in order to be more REST than you used to. Okay, let's hope that my computer won't die. And I'm going to switch to Postman. Okay, and here I have a lot. I hope it's big enough to be seen. Get speakers. It's very easy. It's a get request. You have to press send, and hopefully we'll get back some dummy data. Could not send request. Why is that? Because this is not up and running yet. I don't know why. Wait a bit. Okay, I'm gonna, hoping that that will work, I'm gonna show you the code. Okay, so we have in here an HTTP GET, which is very easy. I think every one of you implemented this, that calls the repository method and returns an OK with that. Another thing that I have in here is to get the speaker by ID. Okay, you pass the parameter in HTTP GET in there just to have the REST, the standard, and you return different things. For example, if you try to get the speaker by the ID and that speaker is not found in the repository, in the database, you should return not found. And if it's found, you should return the actual speaker with an OK status code. Actually, if this is everything that you treat, and you don't add this as nullable and not check it as being different than null and so on, if you return something like OK of this, and the speaker is not found, this will become no content. So it won't return null, it will return no content, even though you haven't written no content there. Another thing that I'm going to show you is maybe you have a scenario where you send something for enqueuing and you want to see if that processing is done. So when you have these kind of scenarios, maybe it's not a good decision to also send the body. If you have the idea of the entity or something that you say, hey, is this done? Is this whatever entity by ID? Is this done? Is processed? Then maybe you should use an HTTP head. And that HTTP head should check if that entity is processed. So how you do that? Simply by using the HTTP head verb. And what it will return or should return is no content, because the head verb as a definition shouldn't return body, shouldn't have body. So you take care of only for the status code. It's either OK and you have no body. It's hey, OK, this is processed, or it's no content. So I cannot find something for that entity. Or you can have different scenarios, but with head requests, the body shouldn't be there. It's like a question that you ask the server, hey, this is done, hey, this is there. And it's the status code's responsibility to tell you if it's there or not. So let's see if, okay, that seems to be running. Fingers crossed. And I'm gonna turn to the postman. Postman. Okay, get speakers, send. I cannot believe this is happening. Okay, finally. So we get a 200 OK, and since we got a 200 OK, we also had the body with some dummy data, okay? But for the head, if you, for example, try to do a head for something that is not allowed, you're trying to do a head for the speaker's endpoint, which means, okay, head about speakers. For head, you usually have something to identify. And what it gives back is, hey, this method is not allowed, at least on the endpoint you're trying to use it, okay? So what you should do is to move on the actual action that you implemented, so which is get speaker by ID, which has, for example, one that I know that is in the database. And if I press send, you'll see that it hits the HTTP head action because it respects the verbs. And as a body, I have row is nothing, but pretty it's one. It's one line. And I also have a 200 OK. So okay, that is there. You shouldn't care about the body. Okay. Okay, but what happens if you want to obtain different representations of the same resource? And the simplest example I will take is JSON and XML. So speakers by ID, if we look at the headers part, you'll see that I want back, hey, as a client, I'm just telling the server that I accept application XML back. And if I'm sending the request, surprise, I'm getting back JSON. But, well, you should take into consideration that I accept XML, or at least if you do not accept what I want, tell me. Give me back a 415 in order for me to know. And that's what's happening is the content negotiation part. So in order to achieve that, you should go back to the API and go to the startup And in the startup, WebEx is eating all my resources. So in the startup, you can configure a lot of things that are API related. So one of the things that you configure is something in the ad controllers. It's something that will tell the platform, hey, do this and that. And one of these is to add options for a few headers and a few behaviors that the API should have. And one of these is options dot return HTTP not acceptable, which is by default turned off, and you should turn it on. So if something that you request is not acceptable, it cannot be processed by the server. It should be responded accordingly. And another thing that you should also do is to respect browser accept header. Otherwise, it will always return JSON because this is how it's implemented to behave. JSON, and that's it. Okay, so I'm going to try to do this. Maybe in the console will work faster. But now, if I will do the request again, that request with the accept and the MIME type application XML will get back a 415. Hey, I cannot use that. Okay, since we're very slow in this, do you have any questions so far? It worked faster. Cool. So I'm wanting back an XML response, and I press send again. And if everything goes well, I shouldn't get a JSON body because I do not want one. Sending the request, waiting for the request. Now, it's 406 not acceptable. So it says that the requested resource is only capable of generated content, not acceptable according to what you sent. So if we look at this request in isolation, the server, it understands that, well, application XML is not something that can be respond with. Okay, and another thing, if you want actually to respond with XML, you should add the contract serializer for the API. So you have in here something that is called configured at XML data contract serializer formatter. So you should tell the platform that you will be able to respond with the same entity, but in XML format. So now, with the same request, we'll get back the right response according to the accept header that we're sending. Okay, it's up and running. So it's the same endpoint. I'm going to hit send. And now the format of the body should be XML looking. What? Of course, if you do not have the accept header, it assumes JSON. So I want XML. Now you have an XML body as being there. On the other hand, of course, if you have specific needs, you will need to tweak this and create an output formatter that is specific to your business. Okay, another thing that we should create now. For example, a body. Let's say we have speakers, and for the speakers we have talks. And this is the way that we change the request. We always want to access the speaker by ID, and then because the talks are related to the specific speaker that is in front of it, the talks will be the chaining entity. So if you have something that is hierarchical in a way, it should be put after the. So you have speakers, and from the speakers you have the specific one with ID 1. And for this specific speaker with ID 1, we have talks. And then if you would have talks with a specific ID, you should have further along the way talks something and the ID for the talk. So let's create something, a new entity, and we should post this. I press send and I'm waiting to send the request. And if everything goes well, we should end up, okay, we have the ID that is assigned now because we posted to properties, we got back 3 because ID is assigned by the database. And also in the header section, you should also have the header called location that is the actual URL for the newly created entity. And now if you take that and we issue a get, you should be able to get the specific entity that was just created. So in terms of status codes, you have 201 created. Okay, and if you get that and trying to run it, 318, you'll see that is the same entity that we created. Okay, now just to create an introduction because we're waiting for this to work. In .NET, you have an API that allows you to specify what are the default behaviors. In terms of it won't work, so I'm gonna just show you the code because we cannot. Oh, that's why it doesn't work. Okay, this is not fun at all. Okay, what I want you to show you is that I'm returning DTOs. So I also have talk1 DTO, so I want to get back the talks for the speaker. And it's nothing else than a simple class with 3 properties. Okay, because I also have a talk v2 because I want to show you the v2 and the versioning of the APIs. And you can also do something like that. So getting back to the talks controller, it's up to you what you return and how you map it. For example, we have the talks controller, CS, which contains everything related to a talk. But I define the root as being everything that is API speakers. You cannot access a talk without accessing API speakers and the speaker ID in front of it, and then talks. So if we were to compare with the speaker ones, which is traditional and it has API controller, the talks, it has a more, let's say, complicated and hierarchical representation of it. And this representation, it depends how you want it. Maybe you want it separately, and then you'll switch back to the same approach, API controllers, and you'll just access talks independently of the speaker. Maybe that's also a business scenario that you can talk. But there's nothing stopping you to chain entities, and it's, as you see, it's very easy to chain entities if those entities are related. For example, if you would have a pets, the pet ID, and then owners, that will be something related to the pet in front. So that might be valid. And then if you have something that is even more complicated, you can add another controller for that specific entity and respect the same pattern. So is that easy to do? Okay. Another thing that I want to show you is that, for example, if you have a create, okay, and that create, that's validation. And we often use this inside our APIs if we don't have another mechanism. We use something like, if model state is valid, then return a bad request. If it is not valid, return a bad request. Or either way, we're checking if the model state is valid for that entity when we have a post or a put, okay? But if you configure something in the API behavior in startup, you can remove this entirely. And this becomes a much easier code, okay? Because it's easier. You remove 3 lines of code at least. It depends on how you write code, the code style. So how you do that is by going to the startup, and I'm going to comment this, and I'm going to add this. So you have the option of using something that is called configure API behavior. And in the API behavior, you have the option of specifying, well, how your API behaves in specific conditions. For example, if there is an invalid model state, so if you post something that is not valid, what you'll get back? So you'll get back something that is called a problem details. You already have an object called validation problem details, where you pass the model state. And in front of it, you can have a lot of things to tweak. For example, if you have a documentation for your project, you can say, hey, the problem that happens is of this type. And the title is maybe generic on, or maybe you have specific for the model validation. And if you want, always as the status, you can have either 422 as being unprocessable entity. You can pass the instance where the bad things happen. And you also have the ability of returning the content type that is standard and it's standardized, application problem JSON in this case. Of course, if you want to treat every model validation as being a bad request, then you can add here bad request object results, and you can change the status code as being bad request. It's up to you how you do this. It's your job to decide this. Okay, and now, because I mentioned that you shouldn't add the 3 lines. If model state is valid everywhere, fingers crossed for this to build faster. In order to achieve this and to be able to configure this, you need to install a package. And that package is not for this, it's for versioning, which is the next part. Fingers crossed. Okay, seems to be running. Okay. No, it doesn't. We wait. Okay, so we have with API behavior, we should post something. I added here validation for the title to not be more than 100 characters, and in here I have more than 100 characters. And what I get back is just by pressing send, I should be getting back the standard response. See, I have this. So this is the type, this is the status code that is received, and also it's sent as the actual response. Where it happens, you can see the errors for the properties, and you also see each and every error. And now I have the validation that I added on the property. The title shouldn't have more than 100 characters. And if I would have more, everything should be in here. But that's done automatically by the platform. You shouldn't check starting this point when you configure the API behavior. You shouldn't add if model state is valid in absolutely every method that you have to check the model state. It removes some code, and it's very nice to have. Regarding the versioning, we have the option. And again, I'm going to show you some code just to save some time with the build part. You can add something, is middleware, add API versioning, where you specify what types of versioning you want. So in this case, I want header API version, and I want a property in the header that is called API version. Okay. Similar, you can add API versioning for the query string, and you can pass it something as a default. It will default to API version. Also, you can have in query string, and you can pass a specific parameter. So at the end of your endpoint, you can add a question mark and the version number and so on. And that would be cool. That will be taken into consideration. Also, you have the option of configuring a lot of stuff. For example, you can specify which is the default API version for you. For example, you can, if you have several versions, you can specify, hey, as the default one, you can have the 2. So I'm ignoring 1, treat the default as being the 2. You can have your API report the API versions in the header, and this will be done automatically by the platform. You can say, hey, if there is no version specified, nowhere, either header, URL, query string, assume that is the default one. You can also enforce this. Also, in the API version reader, you can say, hey, read it from the header and make sure that in the header there is this exact key that you want. Something else that you can configure is error response in case of version mismatch, is the API versioning error provider. You can create your own and you can send the response to the client as you see fit. So I'm gonna try to run this again. And until this build is done, I'm gonna show you in the code how easy it is to have 2 versions of the same controller and to respond, depending on the version you're sending, in different manners. Of course, it's unable to connect. Why would it be able to connect? Okay, so until I show you, I will show you this. You can add an API version on top of your controller, and by adding the API version, you can also mark this specific controller as being deprecated, and absolutely every action inside it will be treated as deprecated. It will work, but it will have a header with the deprecated part. Then each action, for example, if you want to treat differently a specific action, you can add an attribute called map to API version and give it the version. And this will be called whenever this version will be found in the header, for example, if you were using header in there. Or you can add another TOX controller with another name, TOX v2 controller. This is the name, and the name doesn't matter. It matters what you expose as a route, and it happens that you can expose exactly the same route as before. You have API, speaker ID, and you have the TOX. And inside, you can say, hey, I have the API version 2.0. So everything that's inside this controller is 2.0, is in your version. So it's treated the same. So if I'm going to Postman and I cross my fingers, I'm going to show you that you can have 2 versions side by side. For example, for the 2.0 version, you get back 2 properties for each talk. And if I'm going to change this, I'm going to send the request and hopefully it will work. I have 3 properties back. So it's very easy to version side by side. and you can tweak everything just by using a simple library that is called ASP Core MVC version. So I think this is it. Apparently, WebEx didn't allow me to show you more code, but you can find me at the end on Slack, and we will talk about it more. And I also I have this on GitHub. I think this is everything that I can present in an hour during this not moving computer stuff. Thank you for being here.
Thank you.